Into the last session, we have checked about the Sunday cross validation techniques. Even we have worked on the some content as well, right? You guys are there that in that previous session, the Sunday that we have taken a cross validation technique and all because that is important. So that you got the knowledge about this one, right? So why to use cross validation technique and all. These are the things we have discussed, right? Some of you guys not present in that session. Some of you guys visit already present. So cross validation technique that is in most important. Those are in the having the questions, no. So if suppose fixed states are there and what can we do? Data is the same and what how to present your data. So those are the things that will be solved in this part. So cross validation is important task to trust on your model, right? Even tomorrow we are going to work on the performance matrix. So definitely you will enjoy that performance matrix too. Why? Because whatever the content that we have done with the cross validation, no, with the logistic regression also we have discussed, even KNN as well. But two algorithms that we have taken and side by side tomorrow maximum when we go for the performance matrix, that time I will discuss with the random forest as well as the other algorithms. So it will be easy to understand. The stages, ML algorithm stages are same, not an issue. But the content that we have to discuss, that is the content that we are discussing now, that is cross validation technique. So most of the people, they're thinking about cross validation technique is a different technique, or means when we get the answer of the ML operations, means whatever the operations we do in the ML, that is the last, or cross validation is the last. See, this cross validation technique isn't performing differently, right? Why? Because the data we are passing in the multiple subsets. Is it correct? No, multiple subsets we are passing. So why they are means saying that cross validation is there? Because the way we are working on the last content, means last ML operations, the start means start to end. This is a single data set that operating on all the stages, right? But when we pass into the cross validation, then here we are working on what we are working on the different subsets of single data set and applying the same same model means same algorithm and getting a different predictions. So if suppose if you are asking x test is nothing but your test case, no. So you are passing to the model and getting the output. So while doing in the previous one, you are passing what x test and getting the answer. But when I pass the X test to the into the cross validation, you will get in multiple answers because you are there you are using a k-fold cross validation technique. So k-fold is doing, suppose if you are passing k-fold is equals to 5, k-fold is equals to 3, then it is working 3 times or 5 times. He is creating a samples of 3 times and 5 times the way you are passing k-fold size. And once you run that multiple times, you are getting multiple output as well. Means if you are passing X test, you are getting a X test answer predictions 3 times, three different answers. So on the basis of that, you are means deciding which one is in good, which one is in bad. Means on the basis of your on the basis of your voting, right? So yes, uh, just I'm just starting with the oral some basics. So I'll go for that. No problem. I think even I have shared this file as well. Yes, is it correct? But I will check some portal as well. Wait, just a minute. Yeah, actually that is updated. See, I think everyone now, I'm just going to explain these stages. Okay. So what I'm going to do, I will create a new file here and implement that one. Right. So everyone is there. Can I start the work? Import pandas as a PD. Every stage I will explain. Okay, no problem. Import numpy as a np, and you know what I'm going to do. Data set, hard disk data set already shared. I will check link. Wait, I'll check the size of this data set. 1025. But I'll check the size as well. Same. Check out this one. So side by side, I will take some libraries for this one. Okay. First, I will take every library. So need not to go for the passing this always. The first step that we have to do. See, I will write down some theory here. Okay. So check out what I'm doing here. The first thing, data loading, data set load. This is the first step, right? Second stage, what I have to do, data is imbalanced or not. Check data is imbalanced or not. Use imbalancing if suppose there is an imbalancing problem. Okay. Then there you have to use, you have to create Model. Model means X and Y value. Then you have to create X and Y value. After X and Y value, you have to pass fold size. See, you have to pass fold size, define loop for multiple execution, multiple execution on different subset. And then after defining the loop for multiple execution on different subset, you have to define model like logistic regression. Then you see what I'm saying. These are the steps that we are going to work on it, right? You have to define model like logistic regression. Then you should train to your model any flowchart available for this. Sir, you know what, this is I'm ML flowchart is there, but this isn't depends upon the imbalancing problem, means it depends. Then we have to create that flowchart, means if suppose the imbalancing there, then we can go, if not there, then we can like this have to create. I will try to create if suppose written flowchart is there, no, I will create and share with you on portal definitely. Thanks for this idea. Actually, if I get the flowchart, it's more impactful to you explain, right? You should try and do your model custom for each case. Yeah, sir. Actually, if suppose your case test is in changes, then definitely, if suppose your data is balanced, then no need to go for the imbalancing problem. Is it correct? And if suppose your model is already predicting good, then need not to go for the even cross validation technique as well. But if you want to create a multiple execution, multiple subsets, then definitely you should enter into the cross validation. And test cases concepts also different, no? When we go for the prediction, I will tell you each and every stage. You should train to your model in loop. And last one, you can check your output with prediction. Check majority of output. Okay. So these are the steps that we are going to work. Majority of output means if suppose you are asking to the model that that patient is a cancer patient or not, or if suppose that credit card fraud or not. So suppose you have created a 5 folds, and your each fold will give you some output, no, it's kind of true or false, true false. Suppose three of them out of five, three of them giving a true and two are giving a fraud, then majority voting is in true, right? So maximum voting goes to the particular category, then that wins. That's kind of concept that we are going to do. So cross validation technique that he has an capability to implement this. So I'll tell you, let's go for this one. Okay. So once the data is loading, check the data is balanced or not. So first I will go for the data set and pd dot, sorry, read csv r double quote See, there is an this kind of data set that we have. In previously we have done. The first thing we have to check for the your categories are correct or not, means balanced or not, right? So if suppose if I'm first, if my data is not balanced, then definitely that is an it's kind of problem, no? 165 and 138. So what do you think, guys? Can we go for the balancing? Let me know into chat. Yeah. So for the balancing purpose, first, it's not necessary directly goes into the balancing. First, we have to create an independent and dependent variable. So what I'm going to do, create x and y values. Okay. So this is an okay. Check data is balanced or not, and create a x and y values. So x purpose, I'm just going to do dataset dot ilog and colon minus 1 dot values y is equals to dataset dot ilog colon minus 1 dot. Okay. So now I'm going to check first x. This is my x data. This is my y data, right? See now, some of the data is completely like this. Means the data that we have already here, that is in kind of like this. So it's sequential data, right? So whenever you want to go for the balancing, you have to go like how shuffling or randomly, because if you think about the data the way, if suppose if you are passing a random state is equals to 0, then data may gets biasing here. He will directly go for the some maximum voting here. Right? If suppose if you are applying going on this one 20% of accuracy, then definitely random state is equals to 0 and test size is in 20%. Then just see, he will go like this one to 20% this one and 80% like this. So majority voting goes into the one. Is it correct what I'm telling to you? Yes or no? So once I get this x and y, now we are going to work on the okay, work on the data imbalancing technique. So uh, check data is balanced not, create x and not, and balancing. Balancing purpose, what is the next step that we have to do here? To create a random sampler. It depends upon you guys that which technique do you want to use. Say random over sampler. Random over sampler, already we have taken this library. Is it correct? No. And what is the undersampler? You have to pass here undersampler. So I will pass here undersampler as well. Is it correct? Under what happened? Undersampling, not an underload. Okay, like this one. Thanks for informing me. See, work on the data imbalancing technique. So I have passed X and Y. So the collection also we have to pass. No? Do you know the from um, collection import counter? Okay, side by side we can check out the counter as well. So first, what I have done, I will create a X data and Y data because balancing is important. No? So X and Y. See, he's not balancing not only means Y data, he's compulsory, he will go with the X data as well. So whenever you go for the R&D section, no, so means if you want to go for the R&D, it's it's do not go directly only implementation. You have to check that observations are correct or not. The way we have seen, the data is in how much 165 and 138. So output column we should have to check out it. So once I execute this one, no, because X and Y data hasn't that whole journey. So in the print, I will go for uh, my my original data, comma. What is that? My original data is X. Okay, so you have to pass a counter. Why? Because you are checking the count, no? So this is X data. You should have to show, no? But I will check because that that should give the proper answer, but he's not giving. So and unique maybe. Wait, it's kind of np dot Wait, I'm just doing the one experiment here. R is equals to np dot, because we have converted that data into the numeric, no, sorry, numbers, numpy array, because dot value we have passed. So I'll just check out column. Before converting this one, if suppose if I apply this one, yes, we got it. Yeah. See, now we have proper data dot shape, comma, y underscore data dot shape. Okay, 330, 330. Now we have completely balanced data set. Okay, but what we have to do after imbalancing? Let's go for that one. We have to define the k-fold. Which one? Here, check out. You have to create a y model, not an issue. Now you have to pass fold size. So what is the fold size we are passing here? The k-fold size we are passing. So I'm just taking the fold size here. That is this. Define the fold size with the k-fold cross validation technique. Right. So kf is my variable and k-fold is my class. N underscore split is equals to, suppose if I'm passing 5. Okay, you can pass any number, by default value is in 5. Okay, if kf dot get underscore n underscore split n x. So what is the meaning of that? Actually, how many we are getting, the how many times this will execute? No, so 5 times execute. So print kf. If suppose if I execute, you will get this one n split. Now the plus point that we have into the k fold, he can create a 5 folds, not an issue. What I'm saying, he can create 5 folds, not an issue, but every fold has a different data. Means the data, it's kind of random data. I'm thinking about random data because your data is in sequential. No, what is a fold? Fold is nothing but subset. It's kind of subsets. Subsets means you are creating a one. Wait, I will show you that design. That is important. Why we need to go for folds? That's I'm going to explain, sir. Wait. The first thing, the normal. See what I'm saying. In the normal algorithm implementation, you are taking only one data set and applying the whole process and getting the output, right? Only one data set. But when I go for the cross validation technique, he will create us your whole data set is here. He will create a multiple. He will create a multiple subsets, folds, folds, and then he go for the prediction. He can calculate the score of each and every one, and then go for the prediction. So better to go for the directly on the prediction one. He can create a subsets in different samples he can take in the folds and apply the prediction here. And then he can create a multiple outputs. And then you can go, he will give you 1, 1, 0, 1, 0. So majority of voting, who is that? 1, 1, 1. So 3 will win like this subset. Equal because we have balanced. Yes, we have balanced. But the every time data will goes in different manner. Samples are different. But every time. Wait, I'll show you. See, when I create a subset, when I create a fold, he will get he it will looks like this one, right? So everyone has an. This is the same data set, not an issue. But this is your balanced data set. Is it correct? No. This is nothing but your whole data set. So what is the size of our data set? 303. 303 actually. We have taken some different data set or what? Wait, this is a 1000. Wait, I will check differently because that I have given to you that is not in this hard disk. Now, this is in this we test model with all the possible subsets of data set. Yes, Prem, that's correct. Because you are using a single data set for the prediction. No, so you are using multiple subsets for the prediction purpose. So you are getting multiple outputs. And the first point is that you have a single model, means single classifier, that is a logistic regression. So 5 random subsets that you are passing into the logistic regression, getting the output different outputs. That's correct, no? Yes. Is it correct? Are you getting point? I'm going forward here. See, now we have balanced one. What the point? There is an data isn't same. So how can we get a different result? See, data isn't same, but your test cases are changes, no? See here. Now your data, see, this is a whole data set. and the data is balanced. Yes, data is balanced. Data is balanced, but when you are going to train your model, every time your training data set is in changes. No, sometimes suppose, just imagine. Wait, I'll show you one something. See, here we have wise data, and here wise data, right? A total size is in 1000. Total size in 1000, suppose, and you are applying, suppose, somewhat some, no matter how much you shuffle, the data is in same. Yes, not an issue, not an issue. Your data is in same, but when you shuffle, it's not a meaning. But when you create a test cases, every time your test cases are getting different. No, are you getting my point? See, if your y column has an 1000 and zeros and one count is in 500, you know that this is in 500 and this is in 500. Actually, this is, can you please relate with the sample with the dummy card game? Wait, I will show you in the practical. You know, it will be easy when I show the counts, right? Can we go for this one? Wait, I will show you card. Cards are same. Actually, number of iterations and number of observations are here thousands. So it will be good that I can show you from here side view, right? Wait, I will show you. See what I'm going to do here. The way we have got a balanced data set, right? The way we have got the balanced data set, not an issue. The way I'm passing the fold size in 5. So you're creating a 5 folds. The first one, second one, third one, fourth one, and fifth one. So every time you are getting a different. So your test case, if suppose the first iteration hits, the test size is different and training size is different. Second iteration is hits, your test case isn't changed, means test size is changed, test location isn't changed. So every time it works differently. So similar kind of funda you are getting. So every time your whole data set is going to train to the your model, right? So output is getting differently and majority voting wins here. Wait. Now I'm going to pass here my loop, and even I will change the random state here. Wait, I will show you how it is. So I'll pass here random state and shuffle is equals to. So random state is equals to, suppose I'm passing here 3 and shuffle is equals to 2. Oh, sorry. I have to pass this process into where, okay. So split is 5 folds or 5 iterations. Yes, sir. Yes, because you are taking here count kf dot split s x. See, so how much kf count is there? So that much time this loop will execute. Okay. So here, first I will just remove this one, not an issue, and check the code. The first, the train data and test data, because the split will goes into the two iterations. So train and test, the way we have seen in the previous as well, training and testing data set. So x train and x test for the x data. So here we are passing your, here you are passing here x data and x data. Where is an x data that we have created and we have balanced there, x data and y data, because this x data is comes into this one and your y data comes into the y data, right? not an issue. Means you have completely balanced data set. See this one and second one, this. Okay, now you have them balanced, not an issue. Let's go for execution. So here we have the X data for the training test, train data. So that goes into the X train and X test. This is simultaneously that goes into the X test. This is simultaneously goes into the X train. Not an issue. Test cases we have created for the Y data as well. For the test cases as well, means train cases and test cases we have created. This one, not an issue. The way we have passed, check out X train, comma, X test, same concept, Y train, comma, Y test. And here we have passed train underscore test underscore split into the bracket. You have passed X and Y. So similar kind of process we are doing here, but we are not passing test size here. Okay, we are not passing train test size here. What is a train data and test data? What is a train data and test? So this is your count. No, you are iterating number of times, right? You are creating here test data and train data. So that's why we are taking this one. See this one. These are the variables. These are the variables that we have taken for the creating a X train and X test. Here also X train and X test, right? So number of times this will execute as well, not an issue. But when I execute this one, no, you will get to know that how much data that will goes into the train data and test data sheet. Check out. Oh, wait, sorry. You have to pass here values. Wait, because it is taking as a array. Check out. So now every stage we have a different data set. Means different. The count isn't same. This is a training testing set, this is a training testing set, this is training testing set. So 5 times this will execute. That's why we are getting this one shape we have calculated. So how many times each loop will gives us a count, not an issue. But side by side, what I'm going to check, say this is your train data, this is your test data, this is your train data, test, train data, test. So how many times this is getting? 5 times. Why? Because how many folds we have? 5, right? So everyone, train test, train test, train test, not an issue. But the point is that See, I have passed a comment to the upper two sides. So we are getting the xtrain and xtest data. See, so this is your data sets. Okay, this is your data sets. So training testing, training testing third, training testing fourth, and training testing fifth. So this is a test cases that we have passed xtest and xtrain. Simultaneously, side by side, you can pass here ytrain as all data looks same. Hmm, I think test cases are changes. Yes, some test cases are changes every time. Means test cases are changes means, see, test cases are changes means what happen? Your train also changes, no? Means if suppose he is taking the data, that upper side's data is updated into this one training set. So every time data is changes, somewhat data is looks same, somewhat the upper side data is looks same. We'll go for that one also, no problem. Okay, I think I have. We got this one actually. I'll remove this point and pass it into the this one. So you can use the afterwards for the checking purpose. I'm just passing here, not an issue. After that, we have gotten different data in different subset, not an issue. Now the point is that we have to create a logistic regression. So here what happened? So you are creating a multiple subsets. Now you are going to apply your model on this one. Means model means your classifier, right? So here you have to create a cross validation score as well. So cross validation score will get through passing a logistic regression. So for the logistic regression, what you have to do? First, define a logistic regression here. So I'll pass here define logistic regression. So some of the stages definitely will get in confusion, but don't worry, you have to do the R&D here side by side as well. L1 is equals to logistic regression. Okay, so maybe you can pass here random state. Is it correct? No, you can pass it here. 3. So if suppose I'll create a score, SCORE score is equals to uh, cross val into the bracket L1. So cross val score method I'm using here. So L1 comma which data you have to pass here? Can anybody see here? Which data you have to pass? Where is in cross val score? X train and Y train, right? So X train and Y train already you are getting from looping onwards. No? So while loop is going on, that time you will get an X train and Y train. So why not you pass here X train? Is it correct, guys? Comma Y train. If suppose if I remove this line from this one, then only last loop will get into the score values, cross val score, right? CV, you are passing a training data set. The way L1 dot fit into that X train and Y train you are passing, similar kind of structure you are doing here. Score will execute 5 times. Exactly, sir. That's correct. So you are passing here kf because you have created that variable kf here. Cross validation is equals to kf. Kf is nothing but k fold. So now you got the point, that score. So I'll go for the printing score. So every time you are getting a different score here. So check out the score count. See, so 83%, 84%, 85, 85, 82. Okay. So 5 times you are getting the code, not an issue. What I'm going to do? Why not I create a calculate a mean? 84. The mean we are getting how much? 84. 84%. Okay. So see how much, how many times this is executed? 5 times. Okay. So five outputs we got, not an issue. 5 outputs we got, and not an issue. And even we got an 84% average values, average accuracy score, not an issue. But the point to be discussed here, you are getting different data sets, right? See here. So every time your test cases changes, that you have seen in the that when I have printed that data, right? So test cases changes means your data is in changes, not an issue. So while if you are passing the every iteration, your data, your model is learning differently, not an issue. But the second thing that we have to do, if I'm getting a k fold, means if I'm having a k folds, 5 folds, why not I go for the prediction purpose? Right? So what do you think, guys? If I'm passing this test case, means suppose if I'm passing the prediction value into the model, how can I pass? So passing purpose, what I'm going to do? I'll comment this one, not an issue. See, I'm passing here comment and cut it down, passing here. Sorry, not in here. I'll pass here. See, some of the tricks that I'm passing here only. So you can work on side by side as okay. So score that I have created now. But next thing, you are going to predict output. So what type of output you are getting? Ypred is equals to cross val predict. So you are creating already you were created Ypred is equals to L1 dot predict, that previously concept while doing the single subset. And here also we are doing same, but you are doing into 5 subsets. So once again, I'm passing L1, comma, what is your test cases are there? X test, comma, Y test, comma, CV is equals to KF, right? So what I'm going to do here, you are creating a Ypred here, an X test, comma, Y test. So printing here Y underscore pred. Okay, not an issue. So when I execute it, check out this one, second, third, fourth, and fifth. That's it, right? Fifth. So how many times this is executed? 5 times. 5 outputs, right? It's not I'm telling you like you have to pass a group of elements and like that. You have an X test, and X test has some amount of data. So you are asking to the model that let me know the answer, right? So after getting passing the X test, you are getting some amount of uh, predictions here. So why not I check once? See, go with this answer. Last one. Check out the last value. This is an 0. So I'll add here. First one isn't saying 0. Second one also a 0. See, side by side also some checking, check the values. Third one, 1. Fourth is saying 1 because question is the same. You are asking multiple times. That's why you are getting output in a differently. And this is an 0. That's it. So how many answers expecting? How many answers we are expecting? 5. And how many zeros are coming? 3. How many ones are coming? 2. Who will win here? Majority voting. Who will win here? 0. Because maximum voting goes into the zeros. Are you getting my point, guys? His data is a shuffle during the output. Data is during because shuffling means actually even logistic regression is also getting in the random state. No, if suppose if you are not shuffled, then also we have to check for that. 5 different outputs and same date. Yes, actually the same question asking to the 5 models 5 times, and everyone is giving us a different one. 0 0. So who is wins here? Who is going to win? So I think the way I'm getting no, so train test and this is one. Actually, see, it's not like and you have to work on this process as well. Check out the data. What I'm saying, check out the data. Is that data isn't balanced while doing the iterations? Am I correct what I'm saying to you? If suppose you are iterating no test and into the X train and X test. So while doing this iteration, every X test and every Y test is getting balanced data. I think some of you guys will have to get a question like this one because every time if I'm working with the test cases, if I slice down this data randomly, you have an Y's data here. So Y is an completely balanced of 500 zeros and 500 ones. Sub just assumption. If I get a data randomly and slice down the test case here, what is the probability that you are getting a balanced data into the test and train? Am I saying correct? Are the 5 outputs is the same input like age 65? Yes, 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 yes. If you are asking to the model that 65 age people person is getting heart problem or not, so you will get an five outputs, and you, on the basis of five outputs, majority is who which class is in getting majority, so that is in wins. Same. Okay, and please repeat. Okay, the question is that the way I have created a multiple iterations. So what is the probability and possibilities that why not your every iteration getting imbalance into the data set? Because you have passed the balanced data set, not an issue. But when we go for the every iteration, what is the probability that why not we get a imbalancing problem? Can we get the imbalancing into the every fold? Have you checked? Are you getting this kind of question? The question is correct, no? Imbalancing into iteration. Yes, yes, correct, sir. That's the thing that I'm thinking about it. The way we have checked the imbalancing, no. See what I'm saying. The way we have checked imbalancing into that. See, I'll go for one more concept, that is checking the imbalancing. So see, I have taken that code and passing into that. First, I will pass this code into here. See, I have passed here y test so that we can get it the balance. This is balance or not. Okay. So check out. See now. Are you getting something what I'm trying to say that before I have the just before I asked one question to you. So every iteration is balanced or not. See, this is the first iteration 106 and 299. Okay. Second one I'm going to check 99 106. Second one, third one 99 106. Fourth one 94 111, and fifth one 101 104. Are you getting something that we are going to we are discussing about it? Is it possible that you are, please put your mind in this one? So it will be is an interesting fact that we have here. Is it? Means, are you getting something that I'm just trying to tell you why this is imbalancing, and even while going through the k-fold cross validation, that time also we are getting somewhat imbalance. If you guys are means understanding this one and understanding the whole process, that is a good sign for you, because this is an almost we are working on the heart of that ML, the data, actual data you are working on, right? And you are getting these points, then you just have to you proud of yourself that you are understanding every stages, right? This is an interesting fact that you have to implement. The first thing that you have taken this, not an issue, and see how many examples that I have printed here. Means you can able to use this kind of structure. So I have written here, not an issue. So every time, whatever the things that you want, that you can copy here, pass it into that. And the first thing, the sum, if you want to take means unique values. See what I'm saying? If you want to take unique values, so you can store the express data into that, no? So every time you can fetch that express data in from that loop and store into the another one variable. Why I'm telling you like this one? Because as comparatively, if I'm thinking about extrain is getting a duplication of data every time while doing loops. But the point is that if I'm discussing about X test is getting new data every time, every loop. So if I'm thinking about storing fresh and unique data, then I always try to go for the X test and Y test to the storing purpose. Storing means unique data you are getting, no, every loop. That's why, because just see here, if I'm discussing about this diagram, so every time, every iteration, you are getting a new data, no? So test case, X test, and Y test, you are getting new. So every time you are taking a data new, so you can store like this one. So maybe, hope so you are getting what I'm trying to say. Because these are the duplication of data you are getting every time. Is it correct? You got the point. The way we are discussing about cross validation, train can be duplicate. Yes, yes, sir. Yes. That's the thing that I would like to go for this. Train can be duplicates, obviously. And side by side, I'm just want to tell you that if suppose cross-val predict is there, not an issue. The in the tomorrow's session, in tomorrow's session, what we are going to do, that is applying the performance matrix on this. So already one point you have seen, that is about accuracy score. But next point, that is in cross validation. Sorry, not in cross validation. What in confusion matrix. Okay. So if suppose you guys want to know about this one, tomorrow's session, do not miss it, because tomorrow's session is most important for the confusion matrix. And the some questions that I'm going to pass here, that definitely will get into the interview sessions. So I'll pass here. Wait. Okay. What is cross validation? What is getting imbalance again while solving the imbalance. So what should be done? Sir, you know, that just understand the point that if while doing the imbalancing problem, that time the imbalancing isn't huge before we applying the cross validation. So when we solve that problem, after solution, that data, balance data, we are passing into the cross validation, and just check out that problem is not getting that much big. The difference between the balancing, no, it's kind of little bit, means matter of only 10 to 15 values, means the the problem is getting lower, means that getting a solution there. It's not an 100% we are getting means we are removing the balancing. Yeah, only we can minimizing. Yes, that's correct, sir. We are minimizing the balancing problem, imbalancing problem there. Then that's why we can trust. The removing purpose, there is an stratify classification as also there, stratify. Even we have to try that is also. But stratify, first implement this one. Okay, implement this one, work on this one, and only one change you have to do, stratify cross validation score. You have to apply on that. That's it. So that time also you can check that this is minimizing or removing the balancing problem, imbalancing problem. I will show you, not an issue. So how to get a unique data while doing cross validation? So you know that I have just informed you about X test and Y test is a unique data, no? So you can get it through like this, right? Okay. So this is the first part of this one, and simultaneously I am telling you another one. This one, how to get a unique data while doing the cross validation. That is X test and Y test. You can pass here. You can store here as well. This is huge, right? So I'll remove this one because already you have code here. So do not miss if you guys are thinking about we have here. Okay. And what I'm going to do here, I'll pass comment on this one and I will give the name for this is cross validation, k-fold cross validation. So k-fold cross validation. Okay, this is k-fold cross validation. And not got the stratify. I will tell you, no, don't worry. You will get to know that. I'm just taking the libraries here. So I'm changing the variable names KSF. Okay. So this is stratify k-fold. I'll tell you what is the meaning of this one. Not an issue. Oh, actually, by mistakenly, I have made a changes in this one. Okay, this is stratify. So KSF I'm just passing here, not an issue. We are going to check, the balance or not. This is, you'll get to know that everything. So here we are using a k-fold, a stratify k-fold. Okay. we are applying a class of means variable of this one KSF stratify K4. So check out this one. एक मिनट. Split is missing one. Wait, I will check that one. Samples are correct, not an issue. This is correct. This is correct. This is also correct, but wait, I have to pass maybe Y, and here also comma Y because he's checking the count of both, and then I will explain you whole process. 100 and 105. This is minimizing the distance. Okay, 100 and 105. Every time should same 99 and 106. Are you noticing something? The stratify cross validation technique. He's trying to balance the Y data, means your categorical data. So the previously one k-fold cross validation, what is the definition of stratify k-fold validation? That is, he is balancing, he's trying to balance this that test cases, means that you are passing y test and x test. He's trying to balance. That's the work of stratify. So he's always trying to pass a same balancing size to the every iteration. So similar kind of work he has done. So he hasn't solved a complete problem statement like check out the 100 next time also he's getting 100 and the last one he's getting how much 9906. But just get the understanding purpose, he's not doing balancing on the 100 or 9090 or something. He's passing every time same size of categories, means same size of classes to the every iteration. Suppose he is trying to pass the first iteration is an 100 and 105, second iteration 100 and 105, third 100 and 105. But this kind of situation does not having into the previous one in the k-fold. K-fold every time is sharing the different sizes, means 93, 94, 99 every time. Are you getting the difference here? Means you guys are thinking about he's balancing the data. No, he's not balancing. He is trying to fixed amount of test size passing into the every iteration. So that's why he's giving us a this kind of answer. So maybe you guys are thinking about may gets effect on the output. Yes, sure, definitely he is going to affect on the output. But I'll check for the output as well. Check out, I'm just passing here another test cases here. Is this tests data is an always same size? Yes, ma'am, always same size, obviously. If you are not passing same size, then definitely your output is in changes. Output affects. T5 case. So let's check out. The first is an 1, second is an 0. Okay, 0 is there, second one. Third one is an 0. Fourth one is an 0. Fifth one is an 1. See the output, the way we are getting. So previously we got an output like this one, 0, 1, 0, 0, 0, 1. This is an first, not means this is stratify k-fold, and k-fold is giving us output like this one. But at the end of the class, which class wins here? The zeros class is wins because the zeros count is in 3 and one's class count is in 2. And 0 is in final answer. Are you getting something here? What I'm trying to say? Is this the test? The k-fold test data is in different size. Yeah, because there is a different size. Test size is in different. No, 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 no. Actually, what happens? Test size. K-fold is not getting a test size differently. The count of zeros and ones getting different. Means suppose every time the zeros count is different in the k-fold. But just check out in the stratify maximum, he tries to balance the data. The 99 and 106 is there, but every time it's 100, 105, 100, 105 in the stratify. But in that k-fold, your test size is same, but category is getting imbalance. Now got the point? Hope so, guys. Actually, this session is most important. Those guys attended this today's session, they may get valuable points and discussion points, right? Is it correct? So maybe if I'm sharing this file to you, please go to the R&D section, means every time. So I have passed the tags as well, right? And if suppose if you are doing the R&D here daily, if suppose if you are spending daily 1 to 2 hours of in on the different data set as well. So do not go for the only hard disks. You can go for the multiple data sets as well, and try to go for the multi-classification as well. Even we have applied on the binary classification. Why not you go for the multi-classification and go and apply for this? Hope you got the today's session, and even I appreciate your presence here. So thank you so much for today's session. Okay, and tomorrow session, do not miss it. Tomorrow I will explain the performance matrix, and this will helpful to you to understand the performance of your model. Okay, and thank you so much for joining today's session, and see you on tomorrow's. Thank you so much. See you. Bye bye. Take care.